topic here is linear dependence independence. Let's do this example. Determine whether the set of functions 6 to 2 cosine square to sine square is linearly dependent. Definition says f1 of x all the way to fn of x is linearly dependent if there exists some constant c1 cn not all 0 such that c1 f1 of x plus blah 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 plus cn fn of x is equal 0. Alright, so what do we do? Of course, we start just like previous examples. We start with c1 times f1 of x, which is 6, plus c2 times f2 of x, which is 2 cosine square, plus c3 times f3 of x, which is 2 sine square. We set this equal to 0, and then see if we can find constants, not all 0, that will satisfy this equation. Well, I mean, when you see cosine square and sine square, you automatically think about cosine square plus sine square is equal 1. So what we do, the way I think about it, if I let C2 equal 1, if we let C2 equal 1, if we let C3 equal 1, for example, or you can leave it at 1/2, but let's just do 1, then adding these will give you 2 cosine square, let me write it here, 2 cosine square plus 2 sine square, which is 2 cosine square plus sine square, and this is 1, 2 times 1, it's 2. So I want 6, so I want 6 times C1, so I want 6 times C1 to be equal -2, right, for it to be 0. So I want my C1 to be equal -2 over 6, which is -1 over 3. So my C1, I mean, think about it. I mean, if you don't see it, look, 6C1 plus, we said all of this is 2. This is equal 0. If we solve for C1, you will get 6C1 is -2, which means C1 is -2 over 6, which is -1/3. So therefore, there exists C1 equal -1/3, C2 equal, what is C2? C2 equal 1, C3 equal 1, such that C1 times 6 plus C2 times 2 cosine square plus C3 times 2 sine square is equal 0. Therefore, our set is linearly independent. I mean, linearly dependent, sorry. But you can even check it. Let's check it just to make sure. C1 is -1/3. -1/3 times 6 plus 1 times 2 cosine x, 2 cosine square plus 1 times 2 sine square. This is equal what? This is -2 plus 2 factor of cosine square plus sine square, which is equal -2 plus 2 times 1, which is 0. So true. And that's it for this example.